Okay, so it is related to perception, but the motivation for the study comes from, let's say, theoretical debate about the structure of consciousness. And consciousness is one of these difficult questions that I always thought it is difficult to get into, and I was keeping away from it. I am teaching a course in philosophy of mind, so I was interested in the questions. But then there were those two students, PhD students, who came and very interested in philosophy, so we started discussing the issues, and then eventually we came up with running some experiments, trying to deal with some of these questions. So they are Zohar and Noam, they are doing PhD with me, and the other collaborator is Hila Jacobson from Ben-Gurion University, and she's a philosopher who helped us in the discussions. Okay, so what is the question? Let me start with a brief introduction to what is the question. Okay, we speak about consciousness, which means being aware of the world around us, and I will constrain it to visual awareness. But even then, there might be two aspects of consciousness. Those were not often discussed, but a few years ago, a philosopher of mind by the name of Ned Block from NYU, I think he's one of the strong and good philosophers who is very informed on the literature, on the experimental psychology literature, came up with the idea that there might be, within this concept of consciousness, there might be a distinction. The distinction he made is between what he calls phenomenal consciousness and access consciousness. Now let me start with access, because that is what we in psychology are usually speaking about. Access consciousness is what we can report. We see something, we are aware of it, we have access to it. If I will put it in terms of psychology, is what we are able to encode in our working memory. Once we encode it into our working memory, the executive system, sometimes people speak about the global workspace, then we can make use of that information for language, for reasoning, for whatever we need. That is access consciousness. It is thought that the frontal cortex is somehow involved in access consciousness and so on. But philosophers have always been interested in another type of consciousness, another aspect of consciousness, and they call it phenomenal consciousness. Now, phenomenal consciousness is how something feels like. Right? So if you did a course in philosophy of mind, when they speak about consciousness, what is the consciousness of the taste of the lemon, how it feels like. And the same about the color red and the color green, right? They feel different. The red feels in a way, green feels in a different way. And there is a bit debate in philosophy, could we have access without phenomenal consciousness and so on. So let me illustrate this. For example, we know there are patients who suffer from blind sight. So what happens in those patients is that they don't have consciousness about, they do not have they are not aware of the objects that are around there. So if you ask them, did you see that object? They say no. Now we might say they don't have access consciousness. Perhaps they also don't have phenomenal consciousness, because they say, I don't see anything, I don't experience anything. so they cannot report what is there, but sometimes they can kind of guess. They can grab an object, or if they have to guess, they can guess something about that. Okay, so let me illustrate. Maybe I will jump over this. Okay, so let's go to blindside. What NetBlock is using blindside to suggest is, okay, I will nevertheless look into this picture. That's a model of the visual system architecture which he took from Schachter, in which there is a response system. There are some specialized modules of perception, like probably retina, iconic memory, some very specialized modules. There is an executive system, and somewhere in between there is this gateway, which is a phenomenal consciousness. So I see something, and then I have a percept. Now, in principle, there is a gateway between those specialized modules and the central executive, which is this phenomenal consciousness. And what Black suggests is that this phenomenal consciousness, in principle, it is distinct from the information processing. So information processing means that I am processing information and I pass it into this executive system. But that phenomenal consciousness, here it is a gateway. It doesn't have to be a gateway, but it is distinct. In principle, the executive system is here, and the phenomenal consciousness could, in principle, be distinct from it. So he was using this to explain something about blindside. So the idea is that in blindside, the pathway between the specialized module and the phenomenal consciousness is damaged. So that is that gateway. So I am not able to pass information for those specialized modules to the phenomenal consciousness. So I don't obtain phenomenal consciousness, but nevertheless, the patient has no phenomenally conscious experience, and hence the executive system has no information. Nevertheless, the specialized module has a direct connection to the response system, so when the subject is given a binary choice, the specialized module can somehow directly affect the response. Right? So here we are. Those specialized modules, in principle, they should pass information to the executive system through this gate of phenomenal consciousness, but they have another route to the response system. That route is a direct route. It doesn't feel, the person feels nothing, but nevertheless is able to guess that there is a red object or a green object or something like that. Okay, so that is one idea. And now, going back to what is this distinction about? Access consciousness involves, I'm comparing the two types of consciousness. It involves a representational content. So, when I represent something in access consciousness, it always has, it represents something, representational content, it means it represents something in the world. So something is red, it represents red objects. Something is an apple, it's directed to apples in the world. Phenomenal consciousness, it's not so much about representing something in the world, it's about how something feels to me. So there is a huge debate on consciousness about the inverted spectrum. For example, it is at least logically possible that some people would have inverted spectrum. So me and, let's say I have inverted spectrum, so maybe for me green is, I perceive green as red or red as green. In the language, we will refer to the same object, so the representational content is not changed, but the phenomenal content, the way it feels to me, might be different. There is a debate whether this is even logically plausible or not. I will leave this beside. Access consciousness is functional. Once I represent something, it plays a role in the representation, in the information processing, but phenomenal consciousness is sort of less functional. Representational access consciousness is often thought to involve categorical, like I categorize objects, so it's categorical, maybe propositional even, while phenomenal consciousness is more of an analog representation, is sensations. They are not categorical, not necessarily categorical, they can be on a continuum. More interesting for us, I mean, those are things that are kind of implicit in NetBlog, but it's my take on this, so it's a bit of how I see those things. That is something that I don't know that he suggested, but I believe that would be important, that access consciousness is durable, so it involves some kind of maintenance in the working memory system, but phenomenal consciousness could be analog and transient. Okay, so now if we put up such an idea, to come with it, to have some power, it would help to have some dissociations. Can we have dissociations? Can we have one? I mean, usually those type of consciousness go together, and the idea is that they go together. Usually you are phenomenally, you have an experience, and you can report what you experience. So they usually go together. But other situations in which they don't go together. So, okay, so because that starts from philosophy, what would be access without phenomenal consciousness? Well, philosophers have this label, it's called a zombie. That's not the zombies exactly you see in the movies. A philosophical zombie is, well, you might think of it like a robot. It's a person that behaves just like a normal person. You ask him, he responds, you know, what did you have for breakfast, this and that, but he doesn't feel anything. And the idea is, it's again a debated issue, could I have a system that processes information in the normal way, but doesn't have internal experiences? Such a person, if it was possible, would be a zombie. I mean, there are philosophers who say there is no such thing possible. You cannot distinguish. But if there was a zombie would have access consciousness without phenomenal consciousness. Because he can report anything that was shown to him. He can has a normal access consciousness, doesn't feel anything. Now, NetBlog suggests, I mean, in blindsight, what we just spoke, that we can have a person with blindsight able to guess. I mean, they are able to guess to a limited degree. So what he said, if we would have a super blindsight person, a person whose guessing has developed to the degree that he can just work normally and quite going around and everything. So but he doesn't experience, he still doesn't experience anything, but his guessing is so good that without experiencing he's able to do everything as normal. That would be access without phenomenal. I don't think that, I mean, I don't want to pursue this because I don't think it is really plausible to have access without phenomenal. What interests me more is the other aspect. Can you have phenomenal without access? So what would be phenomenal consciousness without access consciousness? I think that is more plausible, and here is a debate I will gonna discuss and the experiments I will show. So that is an example from Bloch, gives an illustration of what would be phenomenal without access. Suppose that you are engaged in intense conversation with someone when suddenly you realize that right outside your window there is, and there has been for some time, a deafening pneumatic drill digging up the street. You were aware of the noise all along, but only now you are consciously aware of it. You were P-conscious, you had an experience of it, but you didn't notice. You didn't access it in a way because your attention was elsewhere, but it's not that you didn't experience. And at the moment that you experience, you also notice you've been experiencing it. Okay, that is the idea. And he's giving another suggestion, a bit more speculatory, about what could be phenomenal without access. He's giving an example of visual spatial extinction. So there are patients, J. Cave reported by Rees et al., that have no perception of faces in the left field if there is an object in the right field. Right? So in that condition, if there are two objects, if there is a single object, the person can see. But if there are two objects in the left and on the right, the person can report only the one on the right, cannot report the one on the left. And the idea is that there is some competition for attentional resources, and one of them wins the competition, the other one loses. But what Ned Block noticed that, nevertheless, for those patients, there is robust activation in the fusiform area for the face in the left side. So, he's putting up the idea that perhaps those patients have phenomenal consciousness. Maybe they do experience the face, but because attention is on the other side, that experience is not making it through the gate of access. So an experience without access. Okay, now in fact, Block came up with this theory in behavioral brain science first time in 1995, behavioral brain science, and then there were a lot of versions and debates around it, philosophy, neuroscience, and there are quite a number of opponents. So here are, people who are interested in consciousness in this field, Dehaene, Quider, and Dennett, and some others. They argue there is no need for a dissociation between those two aspects. And they have a point. If it's more parsimonious to have a theory with less divisions. In order to assume a division, that holds for everything, short-term versus long-term memory. Somebody might say there is a single kind of memory. So if you want to show two entities, you need to demonstrate some benefit, to observe it, to measure it, to show some kind of dissociations. Now, what those opponents are saying is that you can explain all the data by assuming there is only access consciousness, but it has degrees. So it's not that it's only access, it can have access to one level and not access to another level. So we will see some examples in a second. And then we already knew before there is unconscious processing. So maybe there is some unconscious processing. There might be some partially conscious processing at the level of access, and you don't need to invoke this extra entity. Okay? And a big methodological problem. How can you find out whether there can be conscious experience, P, without cognitive accessibility, right? That is the question I want to find out. Can you have phenomenal without accessibility? Because in order to obtain a report, right, the cognitive accessibility is required for reporting my experience. But if I don't have access, I cannot have a report. So how would I know that I have an experience if I cannot report it? So there is a methodological problem here.
So a question about the methodological problem. So the classic example that I had in my mind is the hemi-neglect patient, where you put something in the side that they ignore, and say you put a banana there, and then you ask them, was there a banana or an apple? And they do a forced choice, and they have absolutely no idea that what was there, but then you look at the numbers and they're slightly above chance level. Wouldn't that be methodologically okay? Even because they say they know absolutely nothing about what they're doing, they think they're guessing, but they seem to be above chance level.
Yes, I mean, you see, he gave this example too, visual spatial extinction, it's a bit similar, maybe not exactly, but I think it could go two ways. One way is to say that's subconscious processing. I mean, and yes, we are familiar with explanation of subconscious information processing for a long time via masking, priming. There are lots of ways of generating subconscious, subliminal cognitive effects. And in all those cases, we say there is some activation of the cognitive system that doesn't reach the level of consciousness. So, one option would be to say, in those cases of neglect or extinction, that's what happens. The person didn't experience anything, but there is sub-threshold activation of something, no experience whatsoever, and there is performance higher than chance. But again, at the level of asking them, did you see? They would say, I didn't see. So no access, no conscious access. But he puts up another hypothesis. Maybe they experience it, but they cannot tell you about it. Right? I mean, that's more or less what he's saying. Maybe they do experience it, but they cannot tell you about it. Interestingly, we think that might be the case in visual extinction, but he doesn't think this is the case in blindsight. And probably because he finds here this activation, robust activation in fusiform area, so that he takes the neuroscience seriously. Okay, so let me take this to a more familiar experimental paradigm, and that is Sperling's paradigm. So you all know, yes? Everyone knows the Sperling paradigm, yes?
Just before we go into Sperling's paradigm, can I ask a follow-up question to the question that I asked earlier? So I mean, I understand that there's an academic case to look at this. I'm not so naive, right? But at some level, if you take a kind of like a cognitive perspective on this, you could almost say, well, you know, who cares, right? You know, why is consciousness important in terms of like, if I want to develop some account of some aspect of human cognitive processing?
It might, you know, I will go with you immediately. I say maybe it's not.
Yeah.
I mean, philosophers are caring about lots of things that people on in day-to-day life might think are totally irrelevant, but they care about them very deeply. So, I mean, I think that all the mind-body problem might be, I mean, some will say that it's intrinsically essential, another will say that it's a waste of time. So I wouldn't know to answer this question because, so okay, let's go back to the issue of zombies. So, could there be zombies? Maybe I am one. How would you know? You have no way to know it. Okay. I mean, but I don't know. I mean, then we see those films like Blade Runner, and then you start wondering, do they have feelings, these robots, or they don't have feelings? How is it enough to look at the behavior in order? So there are philosophical problems that have implications, but you can, you know, go around it and say, I will take it to a place where I don't take the phenomenal consciousness so strongly the way that maybe Ned Block suggested it. In fact, I do think of it as what I call a transient awareness. So let's see this, it will become a bit more clear as we go. So I think it will become also more concrete, taking it from the abstract realm to a more experimental, concrete level. So that's the Sperling Paradigm is one of the most important cognitive paradigms in the 60s. What it demonstrates, right, everybody knows a matrix of letters shown for a short time, and then people have to report how many letters they can remember. And what it shows that we have limited access report of about 3-4 items, right? And that is due to capacity of the attentional working memory system. We have a multi-letter array, and we are able only to report out of it 3-4 items. We also know that we have a temporary access which is much higher. So if we queue it immediately, the array has disappeared. But immediately after, we queue with telling people get this row, that row, they can get anything out of it. So we call this iconic memory, and which probably decays within half a second up to a second. It's temporary access. Now, one more thing about that paradigm. If you present it to people, you get them to report letters, they tell you 4 letters, 3 or 4 letters, cannot do more than that. But they also tell you that I saw more. I mean, I saw them, but until I was able to say them, I lost them. So there is this introspection of seeing more items, but losing them just before the report. Okay? And now there is 2 ways to explain what's going on. And those are the 2 views that are related to phenomenal consciousness. But it's framed in a different way. And that is a debate about rich versus impoverished consciousness. So the idea for the rich approach is that when we see this array, we have a rich phenomenal awareness of the display properties, in this case shape and colors, of everything in the array, even outside the focal attention. But this is transient, and therefore it is not transferred to working memory. Therefore it is lost. And there is the other view, which says that outside focal attention we have a very impoverished awareness, which means that inside the focal attention, so we attend to a subset of the array, what we attend we perceive, but the rest we just get some generic, unanalyzed representations. So here is an idea of what it would mean. Let's say that you look at this scene and you have a very rich experience. That's what you feel. That's what your introspection. But then the people who believe in the impoverished hypothesis, they would say at any one time your attentional spotlight might be here and might be here, and in fact you are moving from one to the other, so you do a fast sequence of spotlight jumps, and at each of them you have a strong, detailed perception of what is at your attentional spotlight, but everything else is very low quality, blurred, and so on. The rich experience, on the other way, will say, I'm looking here, I experience everything. So even if my attention is here, I also experience the surrounding. Okay, that is the debate. And to frame it, to make it even more concretely, let's look at a case of a Sperling experiment where we have an array of letters. So here is an array of letters, and my spotlight is focused on an upper row. According to the impoverished view, while my spotlight is here, I see B, F, J, L, and all the other things I don't really see. I know there are letters there, but they are not distinguished, they are not differentiated, they are just some blobs, or I know they are letters, or maybe alternatively they are some fragments. They are not really represented, okay? Now, one experiment that followed from this debate was so somehow a number of experimental psychologists were interested in this debate, and that is a group from Netherlands that was led by is led by Victor Lame, and he has his own theory of consciousness that has to do with recurrent connections in the brain, and he took on the idea from Bloch. And here is a version of a Sperling experiment. You are presented with this for this array for 500 milliseconds, then you have a blank for, let's say, 1.5 seconds, and then a cue telling you to report one of those rectangles. And people are able to do this in 50% of the trials, which means that they, out of the 8, they, how many are here? I think there are 8, they can remember about half, or about only 4. Now, if instead of that you present the cue at the beginning, not surprisingly you can do all the 8, because you pay attention to that one, you remember it, and you are able to do correctly. However, here is the innovation in that study. They a bit trained people, and they presented the cue in the interval, but not at 200 milliseconds later. It could be shown 1 second later, right? So iconic memory was supposed already to decay. I mean, maybe to put it in another way, the debate that we are having is, we know there is iconic memory that has a capacity larger than working memory. But the question is if this iconic memory is conscious or unconscious, right? What they do here is that they present this arrow after the iconic memory has decayed. And often people think that iconic memory might be something which is not really conscious. And what they find that now people can do about 6-7 items. So the argument is that people are able to maintain some kind of representation for a short time, and they called it fragile short-term memory, visual fragile short-term memory. And it is supposed, this visual fragile short-term memory is supposed to be the part of iconic memory that is conscious, is phenomenologically conscious, but is transient. It's not still encoded in working memory. So you can kind of maintain it for a while, and then you lose it if you don't give a cue that will help you to encode. Okay, so Bloch's interpretation of phenomenal consciousness is that the visual phenomenal memory system has a greater capacity than that of the working memory. But it is still not the same as the iconic one, because iconic is maybe higher capacity, but might not be conscious, might be unconscious. Now here is, that will be the last one before I move to my experiments, to illustrate a debate that might be two ways to think about those results. So we speak about those results. So what we said here, people are able to report 4 items, right? In the typical case, they are able to report 4 items. In that case, they are able to report 6, 7 items. Now, what Bloch is asking is, what happens in their perception before this cue arrives? Let's say, one possibility is, because we know that your capacity is about 4 items, is that I have a perception out of these 8, only 4 are represented in a perceptual state. I lost the other 4. That's one possibility. And the other possibility, so that is one possibility, that out of the 8, only 4 of them are still represented. The other possibility is that nothing is represented. So maybe there is iconic memory, but it's unconscious. And if iconic memory is not conscious, so in consciousness we have nothing. Okay, now the cue comes. So what would happen, according to a view that denies phenomenal consciousness, it would say that there was nothing in consciousness, and suddenly, when the cue comes, something pops out from unconscious to conscious. That would be, he would say, that would be strange. Like I suddenly got a percept. Up to now there was nothing, suddenly I get this percept. It is not how we feel. The other option would say, okay, I have those cues that out of the 8, only 4 can be represented, so I still have them in my perceptual system. I am aware of 4 out of the 8, but then the cue comes to a new place. It doesn't come to one of those 8, so then one of the other ones disappears and this one comes up. Again, he says, it's not how we don't feel it this way. So therefore, he believes that it's more likely that during the interval, we do have a transient perception of almost all the array. So it's going back to this introspection of people saying, I saw more, but I cannot report it.
So if you put a mask up between the first and the second display,
A mask.
yeah, a visual mask up, that should wipe that out, right?
It's iconic, yeah.
Yeah, the mask could interfere with this, yes. It will reduce, it's also reducing the iconic stage, and if it's reducing the iconic stage, it will probably also reduce what he calls a fragile short-term memory. A mask will affect the capacity of the system, definitely. Okay, let me go into the experiments. Okay, what we wanted to do is, can we tap on the transient awareness of the rich but rapidly decaying visual information in a Sperling-like paradigm? And to do this, we decided to use color phenomenology with arrays of colored letters. So instead of having arrays which are black on white or white on black, our letters are colored. Now, the primary task that we use is to report the letters either on a queued row or to report the letter on a queued row. And we give feedback for the task. That's what people have to do. But we have a secondary task in which we don't give any feedback. And it is a judgment of color diversity of the array in general. So people have to say first, maybe let me illustrate this. It's becoming, it will be more clear. Those are the type of stimuli we use. So the background is black, the letters are colored, and one of those rows is skewed with a rectangle. And people are told, pay attention, your main primary task is to report, to remember the letters in that rectangle, because you will be queried about one of the letters in that rectangle. So the idea is that people will shift all or most of their attentional resources on those letters. And we are interested to know whether they will be aware about the color in the surround. But what kind of information we are asking about the colors? We don't ask something about are they red, are they blue, are they green, what's the average color? Because here we have this methodological issue. If we would query about a specific color, we believe that without access consciousness, without being encoded, in order to remember a specific color, in order to remember that this one was red, I need to encode it in working memory. I cannot remember it later without encoding it in working memory. But the working memory has a capacity. So if I would have to encode the red into working memory, it will come at the expense of being able to report the letters, because the two things will compete. But if instead of asking specific colors, we ask something that can be judged at a holistic level. So there are a number of tasks that have been done recently showing that people can holistically judge statistical properties. So that was done with sizes of circles and other kind of things. But the type of statistical property we are querying is color, but not average color, because average color would be, again, a bit uninteresting if we go back to this picture. I mean, you can get a feeling that the average color here is blue, right? So even, I mean, I don't have to see the actual picture, right? Maybe I'm totally losing my sharpness of representation, and even without having sharp representation, I can still say it's blue. Therefore, we are not asking a judgment about the average color. We ask a judgment about color diversity. So the argument is, to know color diversity, it is important, at least for a short time, you had access to the individual colors in a differentiated way. If you did this, you can get a judgment of diversity, and we do it binary, high or low, and that is very easy, just one bit of information. Doesn't take much to maintain this, and doesn't need this encoding into the visual working memory. So that is a paradigm. Now, how do we do it? Colors are sampled from this color circle. There are in total here 19 colors, and we have two conditions: a low diversity, in which colors are sampled from 120 degrees, so it can be rotated anywhere. So, right, but you see that even in the low diversity case, there is green and blue, or there can be red and green, or red and yellow, so on. So that is an example of a low diversity trial. That is an example of a high diversity trial. So you can see what people are asked to make a judgment about the color diversity. Here you are supposed to say low, here you are supposed to say high. Now we have an orthogonal manipulation, which is there is a diversity of the queued row, and there is a diversity of the rest of the display. In that case, they are congruent, so both of them are low. Here, both of them are high, but here you have a case where the queued row is high and the rest of the surround is low, and here you have another case where the rest of the surround is high and the queued row is low. Okay? So those manipulations were done. People who are not told, they are told only that your task is to report okay, here is how it's going. So first of all, we present the cue. We want people's attention to go immediately from the beginning to the array and to focus most of their resources at that location. Now, there are 6 letters on that rectangle, so it requires a lot of resources. Nobody is perfect. So as we will see, capacity is around 3. So people are using all the resources, or at least are trying, in order to encode as much as possible of those letters. Then the display is shown for 300 milliseconds. After that, there is a blank interval of 900 milliseconds, and people are probed on one of the letters in that row. They have to say, in this case, R. After that, they are asked, what was the color diversity, high or low? And then the next trial will come. Okay, so in fact, there are a number of experiments. In all of them, people first do a practice in which they only do the letter. They are not asked anything about colors. So they first practice only respond to letters. So we want this to be well practiced. People are learning to do the letters. After they did this practice, we get into the real experiment, and then there are we have here two experiments, a number of conditions. In one of them, we ask people to report the color diversity of the cued row. So that's like more easy for them. So first you report the letter, then cued row diversity. So you already looked at this row. So you might encode anyway the letters. So it's easy. But what are we interested here is, will you be influenced by the surround, despite the fact that you paid attention to the cued letters, because you remember that we have this orthogonal manipulation, so maybe the cued row is low, but we are in this condition of high diversity. So I am paying attention here, will whatever happens in the surround affect me? So that is a question we want to know. But then we have a block in which we tell people, report the letter first, that's important, and then tell what do you think about the color diversity of the rest of the surround, the rest of the array, not the ones that you have been encoding. So can people even say something higher than chance about the color diversity, not at the place where they have been looking at? Okay, so we have another condition here in which we give people some reverse instructions. So what means reverse instruction? We tell them, we instruct them, first look at the colors, decide if it's high or low diversity, and then pay attention to the letters. Okay, so here we try to instruct them to pay attention to colors first. And we did this because there was a suggestion that maybe that's what people will do anyway, because we are asking about colors, so maybe they will look first at colors. And we wanted to see if that will generate different results. Now, what was the thing that we would have liked to see? What we wanted to see is that people are higher than chance at reporting the color diversity, and this has no cost in how many letters they can report. Because if I can report color diversity, but it costs me by I allocate some attention elsewhere, and therefore my ability to report letters is diminished, I think it will not be so interesting, because it will mean that, okay, I'm sharing my attention away, some of the attention, because instead of being on the colors, it's now going elsewhere. So let's see what we find. So I start with letter report, and we look at this in terms of capacity. How many letters people can report out of the array, that's corrected for guessing. And we look at several cases. So for example, if people are doing only letters, here we have a condition that people, after practice, they only do 130 trials, that they don't do anything about colors. Only letters, only letters. So what we find, a capacity of about 3. If they are asked instead of that to report the letter and the color diversity of the surround, the capacity is exactly the same, no difference. And also in the first experiment, no difference if the attention, if we are querying about color diversity of the target row or of the surround, right? You would expect if I using my attention to pay attention to the colors, if the colors I'm asking about the queued row, that will hurt me less than if the colors are around. Then I have to divert my attention from the rectangle, but it doesn't make any difference. However, the only place where we did find a difference in how many items people can report is in those reverse instructions. If we tell people, look first at the colors, so you maybe waste out of the, 1 second, let me just finish I'm wasting maybe 100 out of these 300 milliseconds paying attention at the colors because I instructed them to do that way, then we do find a decrement on reporting the letters. Okay, that is the only condition in which we do find a decrement in how many letters people report. Yes?
So, I think that the language that you're using needs to be very accurate here. Were you telling them to look at the other areas of the display and then look at the highlighted area, the area you wanted them to attend to?
In the instructed conditions.
Yes.
Only in that condition. In that condition, that's what we told them. Pay attention first to the colors in the surround.
This is what I mean about the language, right? I mean, if you told them to look at something, then they will fixate it. But if you told them to pay attention to and keep their eyes still, then they may not have done the same thing.
You have to remember this is shown only for 300 milliseconds.
Yeah,
so I don't think they can make many saccades.
Wait a minute, so let's look at this. We've got 300 milliseconds with a cue. They can't look at anything useful there, but they can position their eyes in a non-optimal position or in a different position contingent on the instruction. The thing then comes on, we've got 300 milliseconds of exposure. That gives them at least enough time to make one eye movement to a different area in the array. We then have a blank interval where they've got an iconic display on, and we know that people move their eyes to look at when you completely remove the stimulus, while you don't have a mask, we know that people will move their eyes within a blank screen to the areas where visually important information relative to tasks
and
is
it
available.
helps to get...
Yes, it does. So what you've actually got is a period of about 1500 milliseconds here, at 1200 milliseconds, where you've got potentially useful information contingent on where they chose to fixate in the display. That's about 4 fixations. Now, I'm not saying that explains the effects at all, but
which effects, for example?
The yellow bar being low. But if someone was told, look at, which is what you said originally, look at the whole display first to try to get an evaluation of the colour judgment, the colour variability across the whole display, and then sequentially attend to the highlighted, the boxed area that you want to make a judgment about with respect to a particular.
That will result in a decrement in the performance of the Q letters?
I think so.
Why? Because I am looking away.
Yeah.
Okay, so I don't know. I mean, we probably would need to measure eye movements, but I mean, I'm a bit puzzled about this because if I have an icon, right, I have an iconic memory and I'm moving my eyes, doesn't the icon move with them or what?
I don't think it does, no.
What?
I don't think it does, no. So I know that there is data out there in the literature where they make something go off and then people continue to look around the blank display at the places. So there's some stuff by all but there's also some other stuff I think as well, isn't there? Do you know?
Yeah, stuff on that.
That was even like it.
So that's right. Well, okay, yeah.
With the disappearing text paradigm where the text goes away
Yeah.
and they look at a blank screen but still show word frequency.
Yeah, so in fact I can do as well. So I mean, I think the disappearing text was slightly different, but I think there is also, I mean, Hayward's experiment is a perfect example. I haven't remembered that one, but I think there are also others where they have objects in and around the display, and what people start doing is looking around the blank display in a meaningful way. So if the icon was fixed on the retina, obviously, I agree with you, they shouldn't look at those areas, but they do. So there seems to
Would
be
it
some,
be like some kind of after images that they are looking at,
I
or?
don't know, there's clearly some representation of the visual display.
Okay. So,
Would you expect a bigger effect then? If they actually move their arms?
Well, one assumes that this isn't going to be a highly like perfect performance. It's a bit of a weird thing that people are doing, right?
but I mean, that is fine. I think.
Yeah,
I mean, that might explain this decrease, but my point is, in fact, here a different one. Why did we do this? We did it in order to argue that in the normal case, people don't do this. Because they could do it always. I mean, the argument is once you start querying with them about color diversity, and we don't do a single trial or something like that, it's possible that people naturally will start looking first at the color arrays, make a decision, even a conscious decision, keep it in memory, and then start, I mean, we argue they don't do it because in the normal condition you don't see this difference. So there is something different in the reverse order. Yes, probably they do something. Either they do it by eyes or by attention, but they lose something there. So
This is data for the work. Oh, I think it's the next slide.
yes?
That's the next slide that you're writing.
Yes.
That's
Okay. Now we are moving to the important part. I mean, that was only how many letters I was able to remember. That's the Sperling kind of. I'm able to report 3 letters. Okay? Now, what about, can I am I sensitive to the color diversity? So what we show here, the actual color diversity, low versus high, is on the x-axis, and probability of people saying high is on the y-axis. And the colors correspond to congruent versus incongruent. So let's look first on the right panel. That is the one in which people are asked about the non-cued row. So that's a more challenging one. I am first have to report the letters. I am told to report the color diversity of the non-cued row. People are able to do it. You see, they are sensitive to that information. And there is also a congruency effect. I mean, that's expected. If the cued row is congruent, is high diversity, and the surround is high diversity, it influences you, but even then, that is, in both of them, it shows the same improvement. People are sensitive. Also, when you ask people to report the color diversity of the cued row, they are sensitive. That's less surprising, but there is a congruency effect here. So the non-cued row affects it. Okay, so in the rest of this, I will only look at accuracy. So I collapse those things, and I look how your response is. So for example, here you are higher than chance at reporting that it is high diversity. Here you are also higher than chance at saying that it's low diversity. So in the rest of the thing, I speak only in terms of accuracy. So what we see when we ask people, that is, 12 subjects in experiment 1, when we ask people to report the color diversity of non-cued rows, we find performance higher than chance, both for congruent and incongruent conditions. And the same when we ask for cued row, and there is this congruency effect. And yes, at the second experiment, it shows exactly the same. If we ask, that's a reverse order. The reverse order, we told people, just look first at the colors. Well, yes, then there is a further improvement. But even without it, people were higher than 60%, about 68% in average. Okay, so what are the interpretations? Probably we have to finish. What's the ending time?
5 minutes ago. How much more feel?
Well, 5 minutes?
5.
Okay. While people observers attend to the Q row to encode the letters into visual working memory, they automatically, what I mean automatically, cost-free, they experience colors for the whole display, and they can obtain a judgment of this color diversity, and we think this is possible because this color diversity judgment involved a binary compression of a high complexity. There is high complexity information with colors, but I just making a summary, high or low. So that doesn't take encoding into visual working memory. Visual working memory requires resources. I just have to encode one bit of information, but I couldn't do it, I argue, without having transient access to differentiated colors. Okay, that is the story. I will jump this one. And okay, the next question we could ask, is this judgment of color diversity based on conscious experience, or perhaps it is subliminal? Perhaps people are just guessing. Maybe they don't really experience, it's not an experience. Maybe they report the letter, and it's just one of those cases of subliminal perception. They guess higher than chance, they didn't really experience the colors. So the last experiment is trying to tackle this, but it's still a bit different. So here we present these colors. I mean, it's an experiment only on color diversity. There is no letters. You don't have, there are letters, but you don't have to report the letters. You see this array. Now it's gonna appear either for 0, 33, or 67 milliseconds. There is a blank interval, and then there is a mask, like a Mondrian mask, of 3 Mondrian masks of colors. And people are asked at the end 2 things. First of all, did you see the colors? Were you able to see the colors? So you have to say 0, 1, and 2. If I didn't see anything, I saw a bit, so that's like an awareness question, or I saw quite well. And then they have to respond to what is the color diversity. Is color diversity high or low in that array? And the result is the following. We look now at the responses divided by what they said. I didn't see anything, that's 0. I saw a bit, and I saw well. For each of these categories, we see how well they are able to guess color diversity. So what we see, if they saw it, they guess very well. But when they reported they didn't see, they are at chance level. So they cannot do it, they cannot guess it subliminal. At least in those conditions, there is no such thing that people were able to guess color diversity. I believe, in fact, we did a similar experiments for colors, just average color. They can guess average color, but they cannot guess color diversity. And the argument is, in order to really see it, you really need to see it. You need to have an experience. You cannot guess it. It's not one of the things that you can subliminally do. Okay, so just to conclude, so far this color diversity can only be done with, I mean, we argue here, right? I mean, I suppose that every statement can be debated, and I'm sure there will be opponents here who will not agree, but we think that it can be done with conscious experience. During the Sperling-like task that we used, observer experiences color diversity outside the attentional spotlight, and it is free of cost to the encoding of the letters into the visual working memory. And we think that the colors across the field are consciously registered, but they decay before encoding into the visual working memory. And yes, we think that this transient activation is enough and we have a transient activation which may be enough for a holistic judgment of diversity. Okay, so probably enough for now. If there are questions.
So can I play the advocate of the devil then and say, so maybe you didn't get the paradigm right?
You mean?
So what I'm saying is that you were trying to tap into that process a little bit of whether people could do something without consciousness, right?
Mm.
I would assume so, otherwise you wouldn't have made this specific experiment.
They can do something without access consciousness.
Yeah, yeah.
I mean, I believe it, I mean, we argue it's still conscious, but it's conscious at a different level, at a phenomenal level. It's transiently, let's leave the philosophical jargon and say it's transiently conscious. It's not durable conscious.
And then your results show that actually for this one they were conscious of it. Because when
They were
said,
conscious of the colors for a transient time. For a short time, they were conscious of those colors enough for them to make this judgment. But then they lost them. I mean, we didn't do this yet, but I believe that if we are going to ask them what was the color at this location, they will be totally at chance level. They don't have access to this information. It's not encoded in working memory.
Quick question, is this transient consciousness low and confident? I'm
Huh?
wondering, is it very low confidence? They're not guessing, but is it low confident? So is it like less confidence than consciousness that would be access instead of phenomenal, or is it too qualitatively different types of
It's
consciousness?
a good question. I don't know. We didn't query people on confidence.
You know they're not guessing, but it would it
I
be
don't think they
high
are
and low?
guessing. I think, but I mean, we didn't. I mean, I think that would be interesting, yeah, to look into. Yes, I don't know. I mean, what is my intuition? That it doesn't have to be low confidence.
Compared
but it
to the
could
letter
be-
judgments,
How?
would it be lower confidence than the letter judgments?
Then,
The letter, judging what letter is there, would that be more confident than judging?
I mean, I
other
think
letters?
also with the letters you are not well, right? Because some people are making errors. I mean, the capacity that is given in this task, I mean, there is a rectangle that covers 6 letters and people are able to report 3. That means that they make a lot of mistakes. I mean, half of the trials they make mistakes, a bit maybe less because there is some guessing, but so even with letters, there will be cases that they probably remember, and probably cases that there will be difference in confidence. Maybe what I would expect is that with the letters, there will be more variation in confidence. So sometimes you got the letter, you have high confidence, and sometimes you didn't get it, you have low confidence. And maybe I would expect with the color diversity it will be more homogeneous, but yeah.
The tasks are quite novel to the subjects. I just wondered if you had any thoughts about what would happen with extended practice, whether the patterns might change.
Yeah, I mean, it is novel, but they had a lot of practice. So, I mean, what would happen in one of the experiments here is that you first do a practice of 100 trials. After you do a practice of 100 trials, or I don't know, maybe 50, I have to check. You do a practice of 50, 100 trials, then you start this experiment. So you have another 130 trials, only report letters. We wanted this in order to be able to look at capacity for letters only, and capacity when you have to do color diversity, so that this is already practice. You don't use it before practice, right? But if you look at the total amount of trials, it's quite, I think it's like an hour. So what would you expect to, what could change if we do, let's say we do multiple sessions? What do you think could happen?
Well, I'm just thinking that with a highly practiced task, the need for the sort of access awareness might sort of decline. So
the access awareness, I mean, with
Conscious
visual,
control processes tend to be more, dominant
in visual,
modern
what,
tasks.
the capacity of the visual short-term memory, like the 3 or 4, I'm not sure if it changes a lot with practice. Perhaps it could improve a bit. Maybe
The discrimination
Yeah.
between the
color
high and the low
diversity.
diversities.
That might improve. Maybe, but I think that what it would involve is, okay, people having better strategies or maybe learning to map the responses. I mean, they experience something. And then it's an issue of how well you learn to tap in this, to bring it into, because I have to make a judgment. Let's say I have information of colors. And basically what I ask people to do is to do a judgment on variance. The low diversity has low variance, the high diversity has high variance. There can be improvement in making the judgment. I suppose it can be, yes. I'm not sure it will say a lot about the availability of the neural representations. So I might have the same availability of these fragile representations, but I'm learning to extract this, the judgment better from them with more practice. Or maybe, I don't know, maybe you can maintain them longer. That's a possibility, but we don't know.
I don't know, I was waving. So do you think that your no cost effect would go away if rather than getting to make a binary judgment on the colour variance, you actually split it into 4 levels, so you've got 2 bits that you've got to use? Because it seemed like your arguments had
it's a
hinging
good
on
point.
it being binary.
Yes,
Yeah,
I
quite
think it
possible.
will become, first of all, it will make the judgment much more difficult, right?
Yeah.
I mean, definitely we didn't want to go that way because we wanted to establish an effect. But, I mean, if we make the color judgment very difficult, I would expect that, okay, there are 2 possibilities. Either people will be at chance level, so they will not be able to do the task because, you know, they don't have enough resources to make for this decision. Or they will start diverting attention to colors, like in what I call the reverse order instructions. So then I will find a reduced letter report. So there are 2 options. Either, I mean, that's what I think will happen. Either, as you suggested, there will be a decay, a reduced capacity for letters, or the letters will remain the same, but they will be at chance level.
So I guess kind of the link question is, what would happen if the extra task that you're asking them to do wasn't based on the diversity of colour, but it was based on the diversity of the letters? So I'm wondering if it matters that the other task is a colour task, whereas the focus task is a form task. So you could imagine where the other letters were only made up of 3 different letters, or they were made up of 10 different ones, and you had to judge what's the diversity of the form. And I wonder if then you wouldn't get the no-cost situation because you're somehow drawing on sort of
I would hope it should work also on doing some diversity on shapes. We took colors for 2 reasons here. One is that in terms of phenomenology, colors is the most vivid example. If you speak about a textbook in philosophy of mind about qualia, that's the technical term that they like. It's always the redness of the orange, the blueness of the sky, so it's a really vivid phenomenological experience. But the other thing is orthogonal. So if there is no cross-channel interference between the letters here, but I would think that it should be possible. I mean, yes, I mean, maybe I would guess that I have to detect the letters on the Q row, and if in the surround there are lots of O's, I would have, or O's and X's, I would be able to say, yes, there were a mixture of O's and X's, or only X's, or only O's. So I would be able to say homogeneous or diverse. Yes.